Hello everyone, this is Dr. M. Srinivasan, Professor and Head of Chemical Engineering, Hindustan College of Engineering and Technology. Today we are going to discuss about crystallization, how the crystal forms. It is very important to know about crystallization because this is very important unit operation in the process industries, particularly in the chemical industries. And also this is the one kind of important mass transfer operation. We can get the crystals at the final during the all kind of separation process. What is crystallization? This is the solid liquid operation. The solute present in the solution that becomes crystallized out at the end of the process. Very simply we can say that high temperature heating and sudden cooling is the crystallization operation, so that only the crystal forms. The figure clearly indicates the solutes, that is the form of initial states that is indicated here, that is formed as the crystal at the final state. It's all because of the chemical potential decreases. Because of the decrease in the chemical potential, the formation of the chemical bonding happens, so the final crystals forms. There are two important steps are necessary in the formation of crystals. First one is nucleation. Second one is crystal growth. What is nucleation? Simply, the birth of a new solute particles is called as nucleation, and the crystal growth, the growth of the nucleus to macroscopic particle size, is called as crystal growth. When these nucleation and the crystal growth perfect, the crystal forms. There is a theory which describes the crystallization operation, that is Moyer's supersaturation theory. What is supersaturation? The saturation process that becomes reversible, and supersaturation may not. Simply, for nucleation and crystal growth, the solution that should be supersaturated. It indicates that may not be reversed. The formed crystal may not be reversed. That is the meaning for that. That involves Moyer's supersaturation theory. The greater the degree of supersaturation leads for the good nuclear formation, and also the supersaturation passes a certain range of values. It exceeds the limit. Nucleus forms is extremely rapid. It leads for the good crystallization operation. Now, I will clearly explain how the crystals forms. At first, there is a formation of the cluster in the solution. It means that the step where the solute molecules dispersed in the solvent, start to gather into a clusters. The solute into the clusters forms on the nanometer scale. That becomes stable under the current operating conditions. What is the operating conditions here? We can consider the temperature, pressure or the operating conditions, so that only the perfect clusters forms. These clusters are stable. These stable clusters constitute the nuclei. However, when the clusters are not stable, if the clusters are not stable, then again we may call that the situation as the initial solute. When the clusters are not stable, they dissolve again. As I clearly explained, the initial state like the presence of the solute in the solution. Therefore, the clusters need to reach a critical size in order to become the stable nuclei. Such critical size is dictated by the operating conditions. As I told already, we can consider the conditions like temperature, supersaturation, etc. And the next stage, the stage of nucleation, that the atoms, arrangement of the atoms in a defined manner. The arrangement of the atoms in the defined manner is called as nucleation, and periodic manner, defined and periodic manner, that is called as crystal structure. Further, that nucleation grows. It means that growth of the crystals, crystal growth, is the subsequent growth of the nuclei that succeed in achieving the critical cluster size. We can simply define this statement as crystal growth. And whenever this nucleation and growth of the crystal continue to occur simultaneously, the formation of the nucleation and the continuing growth of the crystal occurs simultaneously while the supersaturation exists. So, this supersaturation is the driving force of the crystallization. Hence, the rate of nucleation and growth is driven by the existing supersaturation in the solution. So, supersaturation is the driving force for the crystallization process. It is very important to say what kind of industry is looking for the crystallization operation. The industries like pharmaceutical industries, food processing sectors, these two main industries are mainly look for the final optimized product, and the product is to be separated out. For these kind, final optimized production and the optimized separation, the crystallization is a very important process. So that only I told already, the crystallization is a very important mass transfer operation. Yeah, thank you.